And while we are waiting, you can see here that if there are no item on the conveyor won't move. And if there are some object, it will move. I do it to save energy. Okay, 2 items. And while we are waiting, you can take a look at my diagram. It's a bit complicated, but I will explain it. Okay, there are 2 items now. You can see here the picking place stop at the midway when they rotate. Just a bit of time. Yeah, this stop. It's an important characteristic when programming. Okay, enough. Let's move faster. Okay, I jump into the box. And here's my wiring diagram. It's the diagram of a Siemens PLC. And here's the EFU sensor. It has the positive pin and the negative pin to receive source. And if there's an object, if it detects an object, there will be a current run through this pin. Okay, this pin, yeah, the same. I just place a switch here to indicate that if there's the object, this switch will be closed. And if not, it will be open. Remember that is just a symbol, there are no switch in here. And here's the relay. I use relay for the turntable and the pick in place. While the pick in place is rotating, the relay will be closed. And if not, it would be open. You can see more in here. The rotate clockwise and counterclockwise. Here. Yeah, that's how it works. And next is the valve for the pneumatic. It's a symbol. If there's some current run to here, this valve will move to the right, and there would be an airflow to here, and this cylinder would be moved to the right too. And if there are no current, this string will push the valve into the right place, and the cylinder would move to its initial position. And in my diagram, there are just 2 pins, positive and negative, no more. I just want to make it simple. And for the pick in place, they are analog device, not digital. Therefore, we need some driver for it to receive the signal. And for the rotation, it's a bit special because it receives a pulse. If there's a pulse, you can see it will rotate. As I showed you previously. Here. Yeah, a pulse, and it will rotate. And the next is the induction motor. It's pretty simple. Just a relay, just a contactor to control it. And here it's a bit more complicated because it can move in 2 different directions. Reverse and forward. You can see here for more information. If there's a syncing sensor and a sourcing sensor and a syncing PLC. If there's a signal that run through here, yeah, you see. Imagine that this switch is closed and there's a current run from here to here. Yes, okay, receive the current. And for the relay, if the relay is closed, yeah, remember that there are no switch in the sensor. It's just a symbol for you to imagine. Yeah, that's how it works. And for the motor here, if there's a current, the current will run to here. If there's a signal in the output, there's a current running to here and return to here, and this will be closed and the motor will run. Okay, the same for the valve. It will receive the current into this direction and return into the source. For the driver here, for the rotation, as I said previously, it's the same. If there's a pulse, the pick and place will be rotate. And here is also a driver for the pick and place to receive signal. Also in here is a bidirectional motor. If there's a signal in here, the current would run into a relay and this will be closed. Okay, the current return to the negative pole. But if there is also a signal in here, the signal in Q5, the current cannot run through here because this is open. It's a normal close contact, and if there's a signal, it will be opened to prevent short circuit. And here's the same, and we also have a normal open button and normal close button for start and stop. Here we move to the PLC program. It's a bit complicated tool. In the startup program, I move the value 0 to every counter, and I reset the position of the 2-axis pick and place. Also, in the main program, there are many networks, about 47 networks. And here's some characteristic. Here is to control the emitter. If you press the start, the emitter will work, and if we press the stop, it will be stopped. Also, the conveyor is the entry conveyor, conveyor 3. It is this conveyor, conveyor 3. If the turntable is in the right position, and if there's an object in the conveyor will move. Sorry, if there's an object in the conveyor, and if there are no objects in the turntable, the conveyor will move. And also in here, this ladder is used to detect the object in the turntable 1. And the most complicated is the 2-axis picking place. I separated into 9 different stages. As you can see in here, in the first stage, if there's an item for it to pick, it will rotate and then stop and continue to rotate, and then it will drop the item and it will wait for 0.5 seconds and it will return. You can see, as you see previously, in this 2-axis picking place. And also in my program from network 23, here we separated into stage 1, stage 2, stage 3, stage 4, and the graph we run in a few stages. And this is the rotation of the picking place. You rotate in stage 1 and stage 2. Yes, I will send you this program in my file, and you can see it again. It's a bit complicated because there's so many networks. And for my system, there are 5 conveyor, a vision sensor, 2 turntable, 9 diffuse sensors, and now the one important thing is the 2-axis picking place. I think that the assembling process in here is practical because it put 2 items into a box. But in the real system, the item is rarely put on the pallet. You can watch it again. Oh no. My item is moved on the pallet. Yeah. If I press the stop button, this will stop generating objects. Yeah, that's all. Thank you for listening.